Hello there, Mr. Sutton here, bringing you this lesson on the other trigonometric functions. In particular, we're going to be looking at exact values of tan, cosecant, secant, and cotan of theta, and we will be finding these trig functions using our calculators. To start things off, pause the video and write down what you already know about tan of theta. How is it defined? So if you remember back to your SOHCAHTOA days, you might remember that tan was defined as the opposite over the adjacent side. So we're going to take this idea and extend it a little bit to the unit circle. Let's say that we take a right triangle and we draw that on the unit circle, kind of like we did for cosine and sine. So here's our right triangle, here's the angle, and it's the unit circle, so this is a hypotenuse of 1. Now let's talk a little bit more about the other sides of this triangle since we're on the unit circle. This base here, since this is equivalent to the x value that the angle makes, we could call this the cosine of theta. And by the same token, this height here, since that's equivalent to the y value of the angle, that is the sine of theta. Using this idea of opposite over adjacent, we can say that the tan of theta equals sine of theta, that's the opposite side, over cosine of theta, the adjacent side. And this is our definition now of tan of theta. Now, another way that we can define this is we can say that tan of theta is equal to the y value over the x value of the angle, y over x. And if we're talking about y over x, we're actually talking about rise over run. What concept is that? Well, that's the slope. So it turns out the tan of an angle is actually the slope of the angle. And knowing that tan is the slope of the angle actually tells us which quadrant tan is positive and negative in. If the slope is positive, like in quadrants 1 and also 3 down here, even though the arrow's facing this way, it's still positive slope as you read from left to right. If you have a positive slope, then tan is positive. So tan is going to be positive in quadrants 1 and 3. And by the same token, in quadrants 2 and 4, where you have a negative slope, tangent of theta is going to be negative. While we're introducing trig functions, we're going to introduce a few more. It turns out the three major trig functions, by which I mean sine, cosine, and tan, all have reciprocal functions. So for example, we have something called secant of theta that is really just 1 over cosine of theta. And we have the reciprocal of sine of theta, that's called cosecant of theta, that's 1 over sine of theta. And we have the reciprocal of tan, which is called cotan. Cotan of theta is 1 over tan of theta. Now, since this is the reciprocal of tangent, and tangent was also defined as sine over cosine, we can say that cotan is also equivalent to cosine over sine of theta. And these reciprocal relationships work both ways. For example, cosine can be expressed as 1 over secant if we wanted to. Now, we all have three new functions to deal with. We got decent at figuring out where sine and cosine were negative and positive, and we just got introduced to tangent. How can we figure out where these other three reciprocal functions are positive or negative? Well, when you take the reciprocal of something, you're not actually changing the sign of it. It's either going to stay positive or negative. So it turns out that these functions are positive or negative wherever their reciprocals are. So if you're trying to figure out, do I have negative or positive cosecant, for example, you just have to figure out if you have a negative or positive sine of theta. Now, to help you remember these relationships, there is a Quizlet you can go to. I recommend you go here and do the matching game until you are very solid on which of these reciprocal functions goes with which of the original functions. Now that we've met the other trig functions and seen how they relate to cosine and sine, let's go ahead and evaluate some things with them. Tan of 150, how do we get started on this? So the good news is our process is kind of the same. We're going to start by figuring out reference angles because we don't really know anything about the angle 150. So the reference angle on this is closest to the 180 line. We're 30 degrees away from 180, so that's our reference angle. And then for the signage of tangent, well, remember, tangent, that's the slope of the angle. And in quadrant 2, which is where 150 is, our slope is going to be negative. So this is going to be negative tan of 30 degrees. When you get to this point, we're going to rewrite this using only sine and cosine. That'll allow us to use some of those special angle values that we know. So I'm going to rewrite this as negative sine of 30 over cosine of 30. And now I know what the sine of 30 is. That's going to be 1/2. So I'm going to be doing a big fraction here, negative 1/2 on top. On the bottom, I've got the cosine of 30, which is radical 3 over 2. And now we have to simplify the fraction and the radical, so this is going to take a little bit of work. We can multiply by the reciprocal here, same change flip. So negative 1/2 times 2 over radical 3. And then these 2's are going to cancel, leaving us with negative 1 over radical 3. Now, by the way, a shortcut you can take, if you have one of these double fractions and you have the same denominator, you can just cancel out the denominators, so that can save you a little bit of time. But now we're not quite done here. We still have to get this radical out of the denominator, usually to match multiple choice answers. So if you multiply by radical 3 over itself, we end up with negative root 3 over 3. So this is the process you go through. You don't really memorize special values of tangent or the other trig functions. There is just one exception. It is worth memorizing that tan of 45, which is sine of 45 over cosine of 45, which are both the same thing, tan of 45 is 1. That is very much worth memorizing. Comes up quite a bit. Here's another problem for you. Same kind of problem, just a different trig function. Pause the video and see what you can do with this one. All right, so just like before, we're going to find reference angles. 330 is closest to 360, and that's 30 degrees away, so 30 degrees for the reference angle. Secant behaves like cosine. It's really 1 over cosine. And the x values are positive in quadrant 4, to the right of the y-axis. So this is going to be positive secant of 30 when we rewrite that. Now, we don't know secant of 30, but we know cosine of 30. This is really 1 over cosine of 30. Cosine of 30 is radical 3 over 2. So this is the reciprocal of root 3 over 2, or 2 over root 3. And then multiplying by root 3 over itself, we end up with 2 radical 3 over 3. We'll do one more of these here. See if you can figure out the exact value of cotan of pi. All right, so pi we know is really 180. You may or may not need to rewrite this with degrees in order to do the problem. Now, what does cotan actually equate to? Well, there's two ways of rewriting this. We could call this 1 over tan of 180, and maybe you know that the slope of the angle at 180 degrees is 0, or maybe not. You could also write this as cosine of 180 over sine of 180. We know cosine of 180 is negative 1, sine of 180 is 0, so we have negative 1 over 0, which is, ooh, that's interesting, undefined. So these functions that are actually just fractions involving sine and cosine, since they can all have a denominator of 0, they can potentially all be undefined at various spots. For this next part of our lesson, we're going to figure out how to use our calculator to find values of sine, cosine, and all of the other values, or at least use them in a calculator. So below I've given you two values of sine and cosine in degrees and radians mode. See if you can get these values. So sine of 81 equals 0.9877 and cosine of 1.17 equals 0.3902. See if you can get these values by yourself on your calculator. And then go ahead and try these next two when you feel comfortable with the first two that I've given you here. All right, let's see if this worked out for you. So cosine of 205.3, this is in degrees. So on our calculator, we need to make sure we are in degrees mode. So here's my calculator, and I'm going to go to mode and double check that I'm in degrees. So I have a choice between radian or degree. I am in degree, so I'm going to quit out of there. And now I'm actually just going to plug in cosine of 205.3. And we don't have to do any kind of special degrees thing. It's built in if you have it in degrees mode. Press enter, and I get this number, negative 0.9041. Next, let me do sine of 2.2. Now, this is actually going to be radians mode. How do we know that? Because we don't see a degree symbol there. That tells us automatically we're in radians mode. So going back to my calculator, going to mode, I have to go down to radians and press enter on that, and then quit back out. And now I can do sine of 2.2, which comes out to 0.8085 if we round off. So there we go. We'll do one more plug-it-in calculator kind of problem here. This one has a real-life application. So the safest slope of a ladder is up 4 feet for every 1 foot out from the wall, it turns out. So this picture here diagrams a happy state of ladder slopiness. If your ladder is too steep, then you might fall backwards. or if your ladder's too shallow, you might fall forwards. So we want to avoid these situations and just be able to go up and do what we need to do on our ladder without falling and hurting ourselves. So which ladder is going to be safer? A ladder with a ground angle of 67 degrees or 76 degrees? So here we're essentially given the angle, and we need to figure out the slope of the angle. How can we do that? Well, we know from before that if we need slope, it's going to be tangent time, because tangent gives us the exact slope of the angle. So we're essentially asking for tan of 67 and tan of 76 degrees. Pause the video and find those values. All right, so tan of 67, let's plug that in. Now for this, I have to make sure I'm in degrees mode, and I put it in radians before, so I'm going to have to put it back in degrees. Quit out of there. And now I'm going to do my tan button. It has its own button on the calculator. Tan of 67 comes out to 2.3559. And let's do the other one, tan of 76. So let me just grab my input from before, and I'll replace 67 with 76. Enter. And I get 4.0108, which is a lot closer to a slope of 4 than 2.3 and some changes. So it would appear then that tan of 76 is going to be the safer angle. To wrap this lesson up, we're going to graph tan, secant, cosecant, and cotan. So you're going to do this on your graphing calculator. And once you've graphed all of these, see if you can figure out what graphical feature these all have in common. Now, just a hint before you really dive into this. 2 hints, actually. First one, make sure you're in radians mode. And then after you've entered these functions in the y equals, I would use zoom 7, which is a special trig zoom that gives you from negative 2 pi to positive 2 pi on the x-axis. And another helpful hint for you, there are no secant, cosecant, or cotan buttons on your calculator. So you're going to need to use sine, cosine, and tangent. You're going to have to do like a 1 over sort of situation. So pause the video and see if you can graph those out and just give them a quick sketch on your handout. Don't worry about being super accurate, just get the basic shape. All right, so let's do tan first. So on my calculator, I'm in my y equals here, and I'm going to now do tangent of x. And again, I'm going to do zoom 7 to get my trig zoom going on here. So here's the graph of tangent, and that's kind of crazy. It looks like it keeps repeating, but it keeps skipping these spots in the middle. So here's the graph of tangent. Next, we're going to do the graph of secant. Now, if you had trouble figuring this one out, remember that secant is really just 1 over cosine, so that's really what you're entering in there. So let me move the calculator out of the way. There we go, and now let me go to y equals, and I'm going to replace tangent with 1 over cosine. Now, if you really want to be fancy, you can do alpha y equals and pull up your fancy fraction, and then do 1 over cosine. Totally unnecessary. You could have just used division, but I'm going to do it this way. And then zoom 7 again. Here is secant, which is kind of crazy. We've got these little loop-de-loops here that never seem to get closer than -1 or +1. So there's secant. Feel free to pause the video and do cosecant now if you didn't know secant, but now you've figured out how to do these. All right, now for cosecant. So for this one, we're going to do 1 over sine, and I've already got the 1 over, so I'm just going to go up here and replace cosine with sine, and then do zoom 7 again. And we see that cosecant actually looks a lot like secant, but it's just been shifted a little bit to the right or the left, depending on your perspective. So here was cosecant, 1 over sine, just shifted. But now this doesn't really surprise us because sine and cosine are really just the same graph shifted in one direction or another. Now finally we can do cotan. Now you could either do this as cosine over sine, or you can just do 1 over tangent since you do have a tan button. Going back and doing this last one now, y equals, and now I'm going to replace sine with tangent in the denominator. Zoom 7. And here is cotangent. It's kind of like tangent, only we're going down instead of up, and we're also shifted a little bit over. So there they are. So in terms of what you need to be able to do with these graphs, in practice we don't end up graphing these a whole lot. Every now and then you need to graph tangent, but really the things you need to pick up on here that you hopefully notice these have in common is that like sine and cosine, these functions repeat. They are cyclical. They keep giving you the same values if you go far enough. Unlike sine and cosine, these all have another feature. You'll notice that they all have spots where they're undefined. Specifically, they all have vertical asymptotes. So that's another key feature, which means you have to remember these can all be undefined in various spots. So that's it for this one. I think I'm going to go work on my tan. Until next time, Mr. Sutton signing off.